Welcome back to Math 107 College Algebra. In this video, we're going to take a look at the fundamental theorem of algebra and then a result that comes from the fundamental theorem. So, fundamental theorem of algebra says if we're given a polynomial, we'll use a generic polynomial, a(n) x to the n, plus etc., up to a1x plus a0, where n is greater than or equal to 1, and an is not equal to 0. So in other words, we don't have a constant, and that an x to the n is truly the leading term. And then all of the ai's are in the complex numbers. So it doesn't necessarily have to be complex. A real number is a complex number. It's going to be a real part plus 0i. And that's usually going to be what we're going to work with. As a matter of fact, most of the time we're going to be working with integer coefficients. But an integer plus 0i is still a complex number. So if we meet all these constraints, p of x has a complex 0. But now, using the stuff we did last time, so we've found a 0 to that polynomial. So we'll suppose that that 0 is alpha, so we know x minus alpha is a factor. And then we have some polynomial. It's going to be 1 degree lower, so we're going to have bn minus 1, x to the n minus 1, and so on, b1 x plus b0. Well, if that's not, or our original polynomial wasn't degree 1, that's not going to be a polynomial of degree 0. Therefore, it's going to have a complex root. So I suppose I could call that alpha 1. And then I apply that and get an alpha 2, etc. Well, there is a limit if I imply this inductively, which says, going back to our original p of x, an x to the n, and then going in that pattern, a1 x plus a0, can be factored as, now your textbook says a, but actually we can just say an, because it's going to be that same an in the end, multiplied by x minus alpha 1 times x minus alpha 2, and keep on going up to x minus alpha n. And that n is the same n that we had up there. So it's saying we have n linear factors of any polynomial plus that constant an. So if our leading term is like a 2x to the 7th, we're going to have 7 linear factors, and then we're going to have a 2 at the beginning. Well then, if we extend this to zeros, we can say that p of x has n zeros, I'm going to put in parentheses, counting the multiplicity. So, if we had 1 as a 0 with multiplicity 3, when we talk about the polynomial having n zeros, that 0 at 1 counts as 3. So that's going to conclude this video. You'll be happy to know there is no pre-quiz for this, because it's going to depend on some stuff we're going to talk about in class today, or on Tuesday, so I will see you then.